Hi, hello everyone. I hope you can see me and hear me. Great, I can see we've already got a few people in. Fantastic. Say hi with your name and your age so that I know who's joining us and I'll be able to say hello back, give you a shout out. Lovely to see you all here. We're going to start it in a few minutes at 2:00. So in the meantime, just grab yourself a few sheets of paper. That's all you're going to need today. You might want to use some scissors and a pencil, but if you haven't got those, it's not a problem. Don't worry. All you need is paper. Hello, everybody. Grab yourself some paper. Today, this is the live session on the 4th of February. So welcome. Hi, Emma. Nice to see you. From Muxton. Fantastic. You know Mrs. Me then. Wonderful. Nice to see you here. Great, lovely to see everybody here joining us for learning about forces and aerospace engineering today. All you need is paper and we can explore some ideas of forces and become an aerospace engineer for the afternoon. We'll just wait a few minutes till everyone's had a chance to log on. Hi, Kaya. I hope I've said that right. Kaya, nice to see you here. Hope you're as excited as I am. Do something nice and practical. Have an afternoon exploring engineering. I'm so excited for today's challenge. Nice to see you all here. Lots and lots of people starting to log on. That's fantastic. Good. I'm glad that's right. Lovely to see you all. Great. Hello, everybody. Those of you that have just joined us, all you need today is some paper. A few sheets of paper will be fantastic. And you might want to use a pencil and some scissors. Okay. Yes, we're very excited here today to start to think about engineering, and we're going to be doing aerospace engineering today. Fantastic. Okay, so I will start with an introduction to us. If you don't already know us, my name's Mrs. Hale or Lois Hale, and I work here in the Midlands for the STEM workshop as a facilitator, exploring all around the region, lots of different schools and events, doing really fun and exciting workshops with you all you young people that like to explore STEM. And there's also Mrs. Me over in Shropshire, and she also visits lots of your schools, so a lot of you will know her, and exploring STEM with all of you guys. At the moment, we can't be with you in your schools, so we thought we'd do some activities with you online, okay, so that we can explore together and get excited about STEM. So tell me, first question, what does STEM stand for? What does it mean? Fantastic. Science, technology, engineering and maths. And here at the STEM workshop, we combine all those subjects together in really fun, exciting workshops with young people that are also linked to careers. And today, our career is aerospace engineering. Fantastic. Well done, Emma. You got it. Good job. So the science behind this is forces. There's lots of forces involved in STEM and in engineering. So we're looking at some forces, and the design technology element is that you're going to be designing a product. You're going to be manipulating the material to change its shape so that it can do a job. And the maths, you're going to be measuring some things. You can choose, you can measure time or you can measure distance. So today, we're going to be exploring aerospace engineering. Who can have a go at telling me what an aerospace engineer might make? What products do they make? Write your ideas in the comments. Let's see what ideas some people have got. Hi, Emily. Nice to see you joining us. Fantastic to see all you people here getting excited about STEM today. Brilliant. Fantastic. Loads of ideas coming through already. Yes, aeroplanes, also helicopters, anything that goes in the sky. Fantastic. Drones, yeah, rockets, anything that flies through the sky. Fantastic. So take an aeroplane, for example. What is an aeroplane made from? That's where we're going to start. Lots of amazing ideas. What are they made from? Yes, they're made from metal. Lots and lots of different metals have been explored by aerospace engineers, all sorts of different metals. And the material, the choice of material, is all to do with the balance between being lightweight and being strong. Okay, now today, the material that we're going to be using while we're being aerospace engineers is okay. Now, the metal that builds these aeroplanes and other sky flying products comes in a sheet as well. And so, as an aerospace engineer, you're going to need to manipulate and change the shape of this sheet to make it be able to fly through the sky. So everybody now, I want you to get 2 pieces of paper that are exactly the same size. So I've got an A4 piece of paper here. I'm going to get another one. Okay, everybody get your 2 sheets of paper. Okay. Fantastic. I'll just give you a minute to get your 2 pieces of paper. One, I'm going to leave as it is. And the other one, I'm going to carefully engineer to change its shape. You ready? Was that good? Is this really careful, good engineering? I've changed its shape. Okay, and now we're going to do an experiment. I want you to screw up 1 piece of paper and leave the other one as it is. Look how they're different. Exactly the same. Now we're going to do an experiment. I want you to hold them both at exactly the same height. And in a moment, I want you to drop them both at exactly the same time. But before you do that, as scientists, I want you to make a prediction. What do you think is going to happen? Will they fall at exactly the same speed? Will one fall faster than the other one? Okay, make your prediction. When you've thought in your head what you think is going to happen, test it. Okay, ready? After 3, I want you to drop both at the same time. Are you ready? 1, 2, 3, drop them. Okay. This is interesting. What happened? Tell me in comments. What did you discover there? Was your prediction correct? One will drop really fast. Flat paper will fly around. Ooh, interesting, Emily. Yeah, the paper kind of floats around a little bit and the ball falls really fast. Why? The paper ball fell faster. Why is that then? Is it to do with weight? That's a force pulling it down. Surely, if it's to do with things falling, weight has got to have something to do with it. Tell me, are these the same weight or are they different weights? Oh, well done, Zach. It's all about gravity and air resistance. Yes, fantastic. So these 2, exactly the same size paper. I've just scrunched this one up. So they're exactly the same weight. Okay, I know, exactly the same weight. Now, if I open this one back out again, okay, you'll see it's exactly the same. Okay, just scrunching it off. Okay, can't be weight, so it can't be gravity, because gravity is no different. It's still here on Earth. It's got to be the force, air resistance, and sometimes we can call this up thrust if air stopping things falling. Okay, air resistance. Yeah, fantastic. So that's something we can use. That's a bit of science about forces that we can use as an aerospace engineer. Use that knowledge to design our aeroplane. Okay, and it's all to do with something called surface area. Look at the area of this rectangle here, quite large, compared to the area of this ball. And air resistance is affected by surface area, just the same as 2 weeks ago when we were doing water resistance up thrust. Air resistance is the same. So we can use this knowledge. Okay. So now we're going to explore making paper aeroplanes. Okay. Now, if you already know how to make a paper aeroplane, go ahead and make one now that's your design. Okay. If you've not made a paper aeroplane before, then I can show you what to do now. Okay. So go ahead. If you know what to do, make yourself a paper aeroplane. If not, I'll show you now. So you take your paper. Okay. And you fold it in half. So you make the two longest edges meet, and then you squeeze the other side like that. Run your fingers along that fold. So now we've got our piece of papers folded in half the long way. Then open it back up again. Okay, and you can see where it's being folded. Now you need to take one corner and fold it down to that halfway line. Okay, like that. Then you take the other corner and fold it down to the halfway line. So now we've made it pointy. Interesting. Any ideas of why we might make it pointy if we're doing a paper aeroplane? Okay, fantastic. Well done, Sophie. You finished making your aeroplane. Think about the shape of it and why it's that shape. So we've got a point now. Now I'm folding it back lengthways along the middle. So I've got this pointy shape. Is that going to fly? Is that going to work? What do I need to do now? I need to give it wings. Great. So fold down one side. Okay. And then fold down the other side so that it matches. And now we have that typical aeroplane shape. Okay. Now, as an aerospace engineer, we're looking at two different things here because we want our aeroplane to stay in the air, and that's linked with the up thrust. That's the force holding it upwards. And that is caused by the surface area here. So we've got a big surface area of the wings that keeps it in the air. But this piece of paper has got a bigger surface area. Okay. Which one is going to stay in the air longer now? Okay. There's something else we need. Okay. There's thrust. Okay. Because the aeroplane uses a combination of the air resistance holding it in the air and thrust pushing it forwards. It needs to be pointy here to be aerodynamic. I saw Zach saying that really good scientific word there, aerodynamic. It means it's pointy. Okay, so your challenge today is to explore aerospace engineering by building an aeroplane, testing it. And you need to decide what you think makes the best aeroplane. Okay, it could be that it stays in the air the longest. It could be that it travels the furthest. Okay, they're two possible ideas that you can explore about what makes it a really good aeroplane. And then you can measure those things, either the time it stays in the air using a stopwatch, or you can use it on a timer on a phone, or you can measure the distance it travels. So your challenge is fantastic. Well done, Bonnie. The scrumpled up paper fell faster. Good job. So your challenge is to make a paper aeroplane. Decide what you're looking for in your product. Do you want it to stay long in the air, or do you want it to travel really, really far? When you've done that, you need to test it. Then look at what happens and refine it. This is what engineers do all the time. Test it, then refine it. That means look at it and then make it better. And then test it again and see if it's improved. Then change it again and then test it again. And your job is to design and make the best paper aeroplane. Okay, and then get your grown up or your parents to take a picture. You don't need to be in the picture unless you want to be, but take a picture and outline a little bit about what you've done, and then we will choose the best engineered aeroplane to win the prize for this week. Well done, Jack. You did a fantastic job last week and you won the prize last week. Who's it going to be this week? Create a paper aeroplane, test it, make it better, so that you're constantly refining it, make it better and better and better. Okay, so that's your challenge, exploring forces of upthrust and air resistance to become an aerospace engineer and design a paper aeroplane that either stays in the air or travels the furthest distance. Okay. The prize is success. Well done, Emma. The prize is a resource, a box of resources from the STEM Workshop shop. So we will post you a box full of exciting resources. Yeah, from our online shop. Okay. Have a really, really good afternoon exploring and experimenting with aerospace engineering, building yourself a paper aeroplane. And I can't wait to see what you come up with. Okay. Have a really, really good afternoon, everybody. Lovely to see you. And we'll be here the same time and the same place next week, where we're going to have a special Pancake Day edition of YouTube Live. You will need to be in your kitchen with pancake ingredients and a grown-up nearby for health and safety reasons, in your kitchen with your pancake ingredients, and we are going to do a STEM Workshop special Pancake Day bake-along, where we're going to be making pancakes together and we're going to be talking about the science around pancakes, about physical changes and chemical changes. I cannot wait for our special edition next week. I will see you same time, same place, with your aprons on and your tools at the ready. Okay. Bye, everybody. See you next week. Have fun.